Okay, guys, this should be a quick one. If you're sitting down to work on your science fair today, or whenever you go to work on your hypothesis and your experimental design, hopefully this video gives you a little bit better of an idea of what you need to do. So if you look here, you can see that this is due December 11th. Okay, so that is a Friday. December 11th is when this will be due, and I think it'll probably be a week from when most of you are watching this video. If you're watching this, it's probably the day that I'm out. I'm not in the room. You're working on science fair, so it'll be due a week from now. And you can see we've got everything posted here on Blended Schools. And I even have a folder in here now called Science Fair Hypothesis and Experimental Design. And if you click on that, it takes you into the directions. And the directions in here look like this. It takes you step by step on what you need to do. And I said this in class, but remember, this is now a part of the science fair where you no longer are working individual. This is completely group based. So you're only going to have one hypothesis, one experimental design per group. So even if there's 4 of you, you're still only going to have one. Okay, and for the hypothesis, we've done this so many times. You guys know exactly how to make a hypothesis. You use an if-then statement. And here's some examples. Okay, here's some examples in case you forget how to do that. If you need to see more, I can email you more or send you more or do something. But here are some good ones. If galvanized painted steel and steel nails are exposed to water, then the galvanized nails will be the most rust resistant. Okay, so hypothesis, something that you're going to be able to test in your experiment. I know some people might be doing bubble gum. So if we use double bubble, then we will blow the biggest bubbles, would be a fantastic example of a hypothesis for that one. Okay, so there's your hypothesis. And where it gets a little questionable now is when we start to get into some of the other things that you need to have. And so one of those things that I'm going to look up real quick for you is the science fair. And remember, you have this. This should be shared with you. And this is what you're going to be asked to edit. Now yours is going to look a little bit different from mine because you should have your research in there by now. But here's where you're going to put all of your stuff. So your hypothesis, you put it in right there. Your independent and dependent variable and your constants. Remember, constants are things that remain the same throughout your whole experiment. A good example, if we were changing fertilizer in our experiment to measure how much plant growth we had over a specific amount of time, something that would be constant might be the soil or the type of plant that we use or the amount of water we feed the plants every day. Those would be constants. And where I want details is right in here in the materials, because the materials are what is going to tell me what you're using. And you need to be extremely detail oriented. I want you to tell me everything. Everything from whether or not you're using an iPad to if you have any equipment, to if you needed any tape for anything and everything. I want you to tell me your materials. And then the next part of this is your procedure. And your procedure is where we really needed work after the paper airplane lab. You need to be detailed. Using complete sentences, write down the numbered steps that you will follow in order to test your hypothesis. So what I don't want you to do is I don't want you to say, go out in the hallway, test our paper airplane. Well, what are you doing to test the paper airplane? Are you throwing it a certain way? Are you measuring it a certain way? Remember, what I want you to be able to do is go down the hall, give it to somebody who doesn't know what you're doing and say, follow these directions and do my experiment. And they should be able to do it perfectly based on your procedure. Okay, I need you to be very detailed with that one. And that one will go right here, step by step, under the procedure. Now your data collection will go right here. It's a 3 to 5 sentence paragraph. And what you're doing here is you're explaining what data you will collect and how you will collect it. So if you're throwing paper airplanes, you're going to be collecting the distance data, and you're going to be measuring it by having a scale set up and measuring it in meters, and you're going to measure to the 100th of a meter. Okay, those are all examples of what I would be looking for in your proposed data collection paragraph. Now the next part, you get into a proposed data table. And for this one, your proposed data table, you're going to fill out right here. So if we were going to do, let's just do paper airplane. So types of paper airplane and the distance that it is going to fly. So maybe you just do this type of airplane, and we'll go type 1, type 2, and type 3. And then you would do maybe trial 1, trial 2, trial 3, and that is your proposed table. I don't want you to put any data in. That is it. You're setting up your data table in order so that when you're done and you're ready to go, we can just put data in there in your real data table, okay? Don't do anything down here. You see, this is where we get into the experimental data tables. We're not there yet. Stay up here in the proposed data because I have to check it before I let you do anything with it. Okay, so make sure you're just doing a proposed data table, your proposed data collection, and fill out your procedures, hypothesis, variables, and so on. Okay? If you have any questions on this, remember it's not due till next Friday. Ask me when I get back. But tomorrow is your big day to work on it, that Friday. Okay? Hopefully this helps, guys. Let me know if you need anything.